Hello everyone, this is Chidume Nnamdi. Welcome to our next lesson in our Understanding JavaScript course, which is the Understanding the Structuring in JavaScript. We will learn how to destructure or extract values from JavaScript objects and arrays. Let's jump right in. Destructuring in JavaScript is a way to extract values from objects and arrays. It's a JavaScript expression added in the ESC, which is made it very useful for us to extract or unpack values from arrays or properties of an object into distinct variables. Let's see an example. So we'll start with an object. We'll learn how to destructure values from an object. For example, let's say we have a user object like this. It has properties age, 30, name, Chidume. Now we can access the properties age or name using the dot operator here. Like this, you can write user dot age. Excuse me, user dot age, and we'll have access to its value, which is 30. For example, let's say we want to log the age value inside the user object. We'll do it like this, log it. Then if you want to access the name, the Chidume value from the object, we'll do so using the dot operator there. So this accesses the value, that gives us the value, and this here, the age, gives us the value 30. So this logs 30, and this logs the name Chidume here. So this works very well. Now it works very well until we have to access this so many times in our application. Let's say, for example, we want to add our age to 90, or in another case, we want to log our name with our age. So you see how tedious it is to write out user.age and user.name. It becomes tedious for us to do that in every part of an application. But with restructuring, we can unpack these properties from the user object and use those variables without using the dot operator. So to unpack or to destructure age from the user object, we do this. Now, this statement in line 6 destructures or extracts the age property from the user object and assigns it to a variable age. So whenever we access age here, we get 30. So this age has the value of this 30 here, of the value 30. So whenever we access it like this, we have the value 30. So accessing age like that is also equal to doing this. But in this case, we don't have to use user dot again. We only have to use the age, and we can easily access and use the value anywhere. We don't need to use the dot operator. Same with also we can destructure the name property here. We can destructure it. How do we do to destructure the name property? We add a comma, then write out the name of the property. So we can use age and name. So we can use two of them without using the dot operator here. The destructuring we did here is same as assigning accessing the properties and assigning it to a variable, like for example like this. So this is the same thing as the structuring age in this line 6. You can do the same for name like this. It's still the same. So but this is kind of hectic. For example, it becomes space consuming and time consuming if we have more properties in this user object. For example, we have magic here, we have student, and we have matric number. So we'll see that we'll have to, for every added property or any property there, we'll have to be doing this always. So you see how hectic it is. But with destructuring, we simply have to forgo this and do every single thing in a line. Have to do every single thing in a line like this. So, it saves us space and makes our code cleaner. Also, note that we used const there. We can use const, var, or let. They also applies whatever we assign here applies to everything inside here. So applying const here means that const means that the variable cannot be changed. So all the variable we have here cannot be changed. If we have var here, var means it's global scoped and can be changed. So it applies to all variables here. Same thing with let, block scoped and can be changed from that scope. Applies to all variables. So whatever we assign here takes effect to all variables in the all the variables that is in between these braces. So we can also destructure values from the user object in another line. Like for example, like this, we can just destructure an object like for magic user. Sorry, const. Uh, Let me say we didn't destructure it here. Yeah, we can still destructure it here, and it still works. Now, if you assign let here, the let only applies to this. It doesn't apply to anything here. In this case, magic is block scoped and can be changed, but age, name, student, matric are constant variables. They cannot be changed. We can see here everything is done on the same line. We destructured it directly here, but we can declare the variables first, then before the destructuring takes place. This can only be done using the let keyword. Now let's see how it is in place. We can first declare age here, name, before we now destructure it. Name. This won't work for now. To make it work, we'll have to enclose it in these columns or curly brackets for it to work. So did here is to first declare the variables first. We declared it without assigning it. Then we will now destructured the user object, extracted the age property and the name property, and assigned it to these variables here. They will work. So let's console log them and we run it. Example. So it runs, it prints out the name. So late assignment of variables also works in the structuring. Now see that previously we have been using the same name of the property and in the destructuring, but the structuring also allows us to assign a new name to the destructured value. Mind you, the destructured value age and what is here is not the same. Remember that we said this destructured value is just the same thing as doing this. Yes, they bear the same name inside, but they do not reference to the same uh, object in the heap. They don't. They are virtually different. So destructuring is just a syntactic possible way of writing this, but in a single line and making our code readable and maintainable. So in destructuring, we can use a different name, but when using a different name, we need to tell JavaScript the property we are referring to, we want, and now the variable to assign it to. So for example, let's say we want this age to have another name, like for example, user age. Let me say we want it to be like this. We don't want to use age here. We can still do it in the destructuring. So what we have to do is to come here, add a colon, then write user age. What this means that we are telling JavaScript extract age for us from the user object and assign it to this variable user age. So user age becomes 30. We can now log it. Let's run it. See it. So it works. Same thing. We can do the same thing with name. We can say, okay, let the name be username. Can I write it like this? First, this comes, then the variable. So JavaScript destructures the name property into this variable username, and we can also use it. Console.username, it will display 30 actually. Very nice. So you see how the structuring is very powerful and makes our code clean. We can use default values in the structuring. Now default values comes in place when the value we are trying to destructure from the object is missing or is undefined. Let's say for example we want to destructure something like car owner property from the user object. See that we don't have any car owner property here in the user object, so this will give us undefined. It will give us undefined, but in some cases when we are building an app, we don't want a situation whereby we destructure an unknown property or a property that does not exist in the object, and this might cause cascade of errors in our application. So this is where default values comes in place to assign a default value to the undefined property so as to prevent errors in our applications. So to assign default values to extracted properties, we just have to use the equal sign, then next followed by the value, the default value we needed to have. Now in this case, we might write true, or let's say false, because it doesn't occur. So what happens here is that false becomes the default value of car owner property extracted from the user object. If car owner does not exist in the user object or is undefined in the user object, we will not have undefined. Rather, we will have it to take the value of false, and false will be displayed here. Let's see it in play. See it. False appears here. Now let's test other examples. For example, let's extract the age and name. Now here, let's comment out age. Age is no longer here. Now here, age will be undefined, but we can set a default value using the equal sign. Now I set the equal value to 30. Now you see age will become 30. This default value becomes very useful when we are trying to display something, or when we are trying to display the value in the UI. We don't want undefined to be displayed to the users. It will seem as if something is broken. Yeah. For example, we don't want this displays hello, the name. For example, to say hello Chidume, you are 30 years old. But if 30 we extracted is not available, you will see that it will have you are undefined years old. See, it doesn't really make sense, and it shows the user something is broken inside. But now, to mitigate against this undefined showing here, that's where the default value comes in. We just have to add 30 in case there is no age there. We don't have to show 30, so it becomes hello, you are 30 years old. So this is much more better than having undefined in it for better UI UX experience. Also, note that you can still have the value, the property in the user object, but if it is set to undefined, this will still work. This will still work. 30 years old. But if it is set to null, the default value this will not work. It will display null. So in this case, we have to use more than default value. We can now use, in this case, if age is equals to null, we can now write age equals to 30. That it works. We can assign default values to extracted variable names. We have seen this, that we can extract a value to a custom variable like this. Age is extracted and user age holds it. Now we can set a default value to this user age. Now what happens here is age is extracted into this user age, and this user age also has been assigned a default value of 30. So user age takes the value of 30 if age is not available in this user object. So let's assign here, let's set age here to be undefined. Now we test it out. Let's clear, test it out. Yes, you can see we use the user age here, and age is not available here, so it becomes 30. To verify that user age is undefined, let's remove the default value, and we see it here. Good. Now we have been destructuring values from objects like this because we know the name of the properties that we want to destructure. Now what happens in an event whereby we don't know the name of the property to destructure? Like for example, in our application, we have a variable like this that tells us what we want to destructure. Like we have let's just call it var name, and we want to destructure whatever that it in this var name. Like maybe age can be there, name can be there, and we know that this var name represents a property name in this user object. Now we can do something like this: user var name. It works. It prints out whatever that is in this user object. Now we want to destructure it also. We don't want to use it use the property call like that. We want to destructure it. Now what we have to do is to simple first we'll open this square brackets, write in the name of the variable. Now it won't work like this. We must now assign it to a variable name. We'll add this, then now write user var name. Now whatever the variable we want, it must not be this. Whatever this, just whatever the variable we want to hold whatever we destructured. See that this being here tells JavaScript that, see, we don't know anything that's here, so use whatever anything that it's in this var name to extract it from this user object, then assign it to this user var name. In this case, because var name holds the property name, what this will translate to is this. So this is a translation. So this is a computed property. It's not a hard-coded property. So it's computed from whatever that is represented in the variable being enclosed in the square brackets. If age is here, this will become age. Now it will now be something like this: age user var name. Now in this case, user var name will now be undefined, or let's say if 30 is here, it will now be 30. So this is what line 11 translates to. So we can now use, if we log it, user var name, it will give us age 30. If we change this age to name, it will give us Chidume. If we change it to magic, it will give us true. If we change it to matric, it will give us this. So this is how we destructure computed property names from an object. We can also destructure nested properties. For example, let's say we have another property here and it's also an object. For example, we have status object, we have online property true. So have last seen yesterday. Now you can see that this status is a property inside this object, and also its value is a property. We can destructure the properties inside this status object. We can also destructure it. Let's see how it's done. So to do it, now we'll first destructure the property first, status. Then now we want to destructure this status to an new variable. Already the new variable is created whenever we have this we set this semicolon there. Now, but instead of writing out the new variable name, we will add this. Now, why we add this is because status is an object, so we have to destructure it to an object. In fact, if we did something like this, status, this status obj is an object. Now, but instead of writing it there, we will also destructure this status object. And then write out the properties that we want to destructure. Online. Let me recap on what we did here. The user object has a property status, which is an object. Now we want to destructure this property inside the status object. How do we go about it? We'll first destructure status, then assign it to a new variable. Then whatever that is on this right hand side is the value of this status object. Now we already know that this status is an object. Instead of writing it out, we destructure it again. We use these braces, these curly braces, and destructure it again. And then inside it, write out the value, the property name we want to destructure online. If we log this, it will log online. Let's see it. True as online. Or we can just change it from true to online so as to see it play out well. See it online. We can also destructure last seen. Like same way we have yesterday, it's logged. Now whatever we can do in this object, we can also do it here. Now we can also destructure this or assign it to have a default value. We can also destructure it to have to a new variable name. For example, let's destructure this online to have a new variable name like we saw earlier on. So we first add this, then now state the new variable name, status online. Status online. It works. We can also destructure a property value that is not assigned or defined in the status object, and also assign it a default value. Like for example, let's say we have status name. We know that there's no status name in the status object here. It will be undefined. Then we can also assign it to a default value, none. Then if we log it, we will see none there. Yes, that's how it's done. Then also we can also use the computed value, computed property name. We can use it here. For example, let's say we have this var status that holds whatever we want to destructure from the status object. For example, online. Now we can use the computed value, computed property name here. Can now say var status. Now assign it to anything like status name. Now here is online. It will print the value of online for us. You see it? If we change it to last seen, it will print yesterday for us. Now there are more things we can do in destructuring. As you see that this destructuring is a very powerful feature in JavaScript. We have seen so far that we can destructure each and every one of properties in an object. Now, with destructuring, we can destructure one property and also destructure the rest of the properties inside a variable. Let's see it. Now, let's destructure age. Fine. Now, we want age, and now in this case, we need all these properties, but in another object. Now, this is where rest comes in. Rest comes into play. How do we make all these properties to be in a separate object? We'll first do something like this. We'll first add 3 dots. 1, 2, 3. Then now write the variable name. This age destructures to the value of this, while this rest destructures this, all these other properties except age, into a new object. Let's console log it and see what happens. Console log dot. Now we have age, something like age, years old. This is the rest. This rest is a variable, and because of these 3 dots, what it does is to destructure the rest of the property values inside the user object into this rest variable. This rest becomes an object. So now let's log and see what is inside each of them. You can see age is 30, while rest is an object. In fact, let me log them in different lines so we can clearly see them. Let's clear our console, then log. You can see it. Age is 30. Then rest is the rest of all the properties in this user object. So what this does is that it gathers all these properties and adds them to an object and assigns it to this. So this can be any name. This rest is just the name of the variable. We can say something like this, others. It still goes here. So it's just the name of the variable. So that's what happens here. So whatever we add here, whatever we destructure before this, it removes it from this rest, or from this thread dot destructuring. This is what we call the rest in JavaScript. By doing this, this is what we call rest. So if we destructure name, now name will be removed from these others. We will no longer have name here. Look at what we have. It will now have magic. It will now start from magic student. So that's how it goes. If we destructure matric, it will not have, these others will not have age, name, matric in it. So it will have, these others will contain the rest. So that's where the name comes from. It will contain the rest of the properties, not destructured. So that's how it happens. So this rest is a very powerful feature in JavaScript. It lets us access other properties that was not destructured from the object. So that's a very powerful feature. Then there's one thing also we want to test. Let's see if others reference to this same to its parent object that it was destructured from. So to do it, we will use the triple equivalence operator. So as we can see first here, this means that others, or these rest arguments does not point to this user object or to its parent object. It does not point to it. So it's just JavaScript copies it, creates a new object, and adds all the properties that were not destructured inside it. Object destructuring is very powerful, and we can use it in function arguments. It's very useful there. Now, for example, we have a function. Let's say we have a function. Let's just call the function x, and this function takes an object. Very good. Now, inside this object, inside this function, we want to return the age value inside the object. We can write this function like this, but we can make use of destructuring so that we don't have to use the dot operator or write the argument like this. We can use the destructuring to make our code readable. So inside here, this argument, we can destructure this object because we know that this is an object coming in. For example, we can call x like this with user. So we know that this argument user is an object. So we can destructure age from it. Can do it like this, age, and simply return it like this. You understand? We know that what is coming here is an object, so we destructured it like this, age, and now returns it. So inside this function, we see this age as a variable that holds the destructured value of the age property in the user object here. So this is a very simple way to use the structuring and the arguments of a function. So we can call our function here and log it. Let's clear our console and log it. It logs state. Now, what if we are trying to return age and name? We want to use it inside this function. So we have to destructure the name also, and we can use it. Also, we can use it also. So let's log it. Now, we can also use rest here. We can use rest also here. And we can get the rest of the properties here. So let me say we're trying to check if uh, to, re to return the age and name if the user is online. So we can just like use rest here. Say rest or status.online. If it is online, we'll just return so you see it. Rest. We can also use rest in the argument of a function. We can also destructure instead of using uh, accessing online like this. We can also destructure nested objects like this status. We can destructure online from it. Simple. We'll come here. We do status. We destructure it and get online from it. So we can simply just do this. Oh, sorry, I didn't remove this. So let's clear. Very good. So also we can also destructure the properties to a new variable. Like for example, you don't want age, we want to use a new variable to it, like user age. You can still do it here in the function argument and it still works. We cannot change age through it and it still works perfectly. So we have seen how we can also use rest in an object argument. It works perfectly there. And also we can also use a computed property name here. It still works. So far we have been looking at destructuring in object. Now we will look at destructuring in an array. Now we have this array fruits that has elements apple, banana, orange, mango, lemon. To access each and every one of the elements inside this fruits array, we will use the index based approach that we already know. Fruits 0. This references to the first element in the fruits array, which is apple. Fruits 1. This references to the second element, which is banana. Then orange is 3, mango 4, this one 5. So as we know, arrow indexing system begins with 0, 0, 1, 2, 3, 4. To access banana, see the same thing, fruits 2, this gets banana. So we can now come here and assign apple, banana, orange, then mango, and last lemon. Now you see, just to access the 5 elements there, we have to write codes on each line for all of them. Now, instead of doing this, we can destructure all the fruits in one line. Look at how we do it. First write. Then in this case, we'll use the brackets. Then first assign it to fruits like this. Then we will write out the name of the variable we want to assign each element in the fruits to. Now, easily for uh, identifiable case, let's extract apple. Now, this variable is assigned to the first element in the fruits array, which is this apple. Now, note the name here in this case is not the name of the element in the array, which it is totally different from what we saw in the object destructuring. This easily tells us that this is the first element. In fact, we can even leave it as A. This is the first element in the array. B, second element. C, third element. D, fourth element. E, fifth element. So A corresponds to the first element in the fruits array. B to the second element. C, the third element. So this A will print out this. B is this. C is this. D is this. While E is the last. So let's log them and see. Let's log A. You see A is the first element, which is apple. Let's log B. Banana. Let's log C. Orange. Let's log D. Mango. Seed. Then the last one, E. Lemon. So this is how the structuring in an array occurs. We first write out the brackets. Now, the sequence of the variables inside this square bracket separated by a comma corresponds to the index, corresponds to the arrangement of the elements inside the array. The first ever variable consists to the points or references or stores the value of the first element in the array. The second element likewise stores the second element in the array. The next one likewise, and so on. Mind you, the value here is just a value name. So this A is just like doing this. So it does not correspond to the name of the element. We just have to write it, for example, we have to write it like apple here. So as we know that this is pointing to apple, just for clarity's sake in our code. So that's how even codes are written, so that you know what points to each, so that whenever you see this, you know that okay, it's pointing and its value is an apple. So second one, banana, points to banana, to the second element in the fruits array. Orange, mango, and lemon. So all the names here does not mean it must take the name of the element here. So we can even remove this to be a string and it will be true. It still works. It will print true. Not that it will print lemon. It just prints the value it is being pointed to, which is true in this case. See it. So that's how destructuring works in an array. Now we can also declare a variable before assigning it to the before assigning it to the destructured value. For example, we can have here apple is not yet assigned, but we can come here like this and say apple fruit, and we can log it. So also we can even write banana and also come here destructure it, and also it works. Yeah, so whatever we saw in our object section, we can also do in an array. We can skip items in an array during destructuring. Let's say we want to destructure apple, but we want to skip banana and get orange, skip mango and get lemon. This is how we do it. We'll first now we destructure apple. To skip banana, we don't have to write anything. We just have to add another comma. So you see the first item destructured, the second item was skipped. It was destructured, but it was not assigned to any variable at all, so we can't get hold of it at all. So now let's destructure orange. The next one we are destructuring will be the element after the one skipped. Then let's skip mango. Nothing. We'll just add the comma operator. It skips mango. Then we'll now get lemon. So like this, we destructed apple, skipped banana, destructed orange, skipped mango, and destructed lemon. So skipping an items during destructuring in an array, we do it by assigning an empty value to the destructured element. So let's log it. Let's clear the console. You see, we only get the destructured elements. We don't have the skipped element. Then we can also skip all elements in the array. So what we have to do is just to do it, we remove this, remove this, remove this. So it skips everything in the array. We know that this space is for the first element, second element, third element, fourth element, fifth element. So you see it corresponds to first element, second element, third element, fourth element, fifth element. So everything is undefined. So nothing was found, not defined at all. Nothing was found. So this is how we skip all elements in an array. So this feature is one feature that's commonly not popular in the JavaScript world, but we can even also see it when we are using hook. For example, in our React application, in our state hook, we do something like this. We do something like this. And we know in Java, in React, this state contains both, is an array that contains both the first element there is initial state past here, and the second element is an update function. So we can just access it simply like this. State 0 gives you the first element, and while state is a function. So instead of writing the code like this, you can see it that we simply write, even in the React docs that we do it like this. Oh, this accept. We do it like this. We use the destructuring. We'll first write this initial state, then we now write set state. So we can see this is the structuring going on here, because we know that this use state returns here an array. So it returns an array. We now destructure it. Instead of doing this everywhere in our application, we just simply destructure it in the same line we call the use state hook. Then we know that the first element is a state, so we assign it this, and the second element is a function. So we can now call the second element is state like this to update our initial state. So we can see a practical example of where array destructuring is being used in the real world. Now we have seen how to destructure elements in an array, but what if we want to assign some of the array to variables and the rest of the items in an array to a particular variable? Let's see it here so that we will understand what we want to do. We have apple here. We destructured apple here. But also we want the rest of the elements in an array. We want to be able to get them. We are working with apple, but also want to get the rest of the non-destructured values in that same array. How do we do it? We simply add comma, then add 3 dots, 1, 2, 3, then followed by the name of the variable we want to assign it to. You can write it other fruits. So this takes the first element in the array, and this is an array that contains the rest of the elements. Let's see it. Apple, then others. You see, the first is the first element, while other fruits is the rest of the elements in the array. This is not an array. It's just it takes the value of the type of the data it holds. In this case, a string. So only this is an array that contains the rest of the elements that were not destructured. So let's say we destructure the second element, banana. Now, other fruits will contain other elements except apple and banana. These two will be excluded, while orange, mango, lemon will be included. So it will not print this. It will print this: orange, mango, and lemon. So whenever we destructure a value, it removes that from the rest. It's not included here, so that we can be able to still access the other variables. So this is very important whenever we are destructuring values in an array. We can unpack and assign the remaining part of an array to a variable. Now there is a case whereby we destructure a value or an element that is not in the array. Not that it is not in the array, but it has exceeded the number of elements that is in the array. For example, let me trim this down to 2 elements. we destructured apple and banana. Then we try to destructure orange. There is no orange in the array. There is no third element. Orange. There is no third element in the array. So this will throw an error. This orange here will throw an error. Let's try accessing it. So you see it. So we don't want to have undefined. For example, we are trying to log the third element, this orange, in the console or in the browser. We want to display it. Then user seeing undefined is not a very good user experience. Let's see. So see, undefined is the third fruit. This is not a very good user experience. We don't want to see undefined. Yes, there is no, we know that orange does not exist in the fruits array. So in this case, we have to assign a default value to the destructured value of orange. What you have to do is use the equal sign, the assignment operator, and then add the default value. So in this case, orange does not exist in the, let's save it. Orange does not exist, or the third element does not exist in the fruits array. So, but in this case, it will take the value of its default value, which is orange in this case. And now we will see that orange is the third fruit. So this is to mitigate against undefined values, because our log or our display in the browser might run before we get the fruits, or before the orange or the third fruit is populated in the fruits array. So we don't want to be seeing undefined in our screen. So we just need to assign it a default value, so that we can have a very good user experience and see the default value instead of undefined. Now also, we can destructure an array. We can destructure an array passed to a function. For example, we have a function x, then we call it with the fruits. So we know here that fruits is an array, and we just want to return the first element like this, the first element. So we can destructure, instead of doing this, we can destructure the fruits like this. So instead of doing this, we just simply remove it and write apple, and we'll log it. So we can also destructure the second element in the array and return both of them. Let's just return a string concatenation of them like this. It returns both of them. So we can also even assign use the default assignment here like this. Orange is not available, but we can also still add it and it returns. And also we can still use rest here. Let's say we have orange here, and we have apple, and we just want to assign apple and just return the rest of the fruits in an array. So we can use rest here, then return apple. See, tick apple. and other fruits. Or to make it nicer, we can say we have an apple, and we can now get length of the fruits. I can now have dot length 3 other fruits remaining. So you see it with the structured one, and we have the other fruits array contains the rest of the two. So we now say we have an apple and 2 other fruits. So you see this is another practical example where rest is very useful to have. Yeah, because without this rest, we can now we will start slicing and splicing here so as to get the other fruits in the array. So but with the rest, we can simply get the rest of the fruit excluding the structured element and then use it. We can swap values in variables using the structuring assignment. Now let's look at it. Let's have 2 variables here. Let's say a holds 1 and let b holds number 2. Now we create an array. Now the first element in array is b, while the second element is a. Now let's destructure this array that we created. We do it like this. Now in this case, we assign the destructured first element to a and the second element to b. Here, this array, the first element b is 2 and the second element a is 1. Now we destructured it, assigning the first element to variable a. Now the first element here in this array is 2, so it will not assign this variable a to hold the value 2, while assigning the second element, which is being destructured from the array, whose value is 1, and assigns it to this variable b 1. So before this destructuring, a holds the value 1, b holds the value 2, but after this destructuring, the values between a and b is now swapped between them. A holds the value of b 2 in this case, and b now holds the value of 1, the previous value of a, which is 1. So here, this line 4, the destructuring is just like doing this. A is equals to b and b is equals to a. So this is what was done on line 4. Now let's test it out. First, let's log the values a, b. Let's be sure a is and b. So let's copy it and console log it here after. So you see on line 4, initial a is 1, b is 2. Then after the destruction, a holds the value of b, which is 2, and b holds the initial value of a, which is 1. So in this case, we were able to swap the values between 2 variables using the destructuring assignment. Yeah. So this tells us like how powerful destructuring is, and to be very careful when destructuring, and very careful of the value of the variable we are destructuring the values of the array to, so as not to change the previous value of that variable. Yeah. Thanks for watching this lesson, and I hope you enjoyed the lesson. And I also hope you understand destructuring, what destructuring is in array and also in objects. You understood assigning default values, destructuring to variable names, how to use destructuring in the arguments of functions, and also assigning to computed property name. I hope you enjoyed this course, and thank you so much. See you in the next lesson. Thank you.